I am Professor Raghavendra MJ, Department of Mechanical Engineering, SVIT, Bangalore. Today I will give you some introduction about the basics of mechanical vibration, which is coming in module 4. Okay, so overview of this introduction is what is into a vibration, what are the causes of vibration, what are the effects of vibration, how to prevent the vibration, what are the different types of vibrations. So I will tell you what is into a vibration. A motion which repeats itself after certain interval of time may be called as vibration, or the to and fro motion of a body about a mean position is called as a vibration. For example, if you take a simple pendulum, okay, so it will oscillate about a mean position. There is a to and fro motion of a pendulum about the mean position is a best example for the free vibration. Okay, what is free vibration? Whenever you give some initial displacement and leave, it will oscillate on its own. For example, pendulum only. After giving the initial displacement, it will oscillate on its own about the fixed position or a mean position. This is called as a free vibration. Example is a simple pendulum, and vibration of a tuning fork is a best example for a vibration. Next, not only these two, there are many mechanical structures, mechanical members, okay, which are having rotating and reciprocating parts will vibrate. Okay, so all the structures and machine members, okay, will have a vibration which are operating under high speeds. What are the main reasons for vibrations? What are the main reasons? That is causes of vibrations. Maybe the first main important reason is unbalanced forces due to rotating and reciprocating parts of a machine. That is inertia forces like centrifugal forces. If those are not properly balanced, then there will be an imbalance in the machine member. Then it causes a vibration. That is, in order to avoid the vibration, all the forces which are developed in a machine member due to operating of various parts should be minimized. That is, all the forces should be balanced. Next, elastic nature of the system. If the system is too elastic in nature, then that also leads to an vibration. External excitation applied on the system. Okay, so now if you apply some external agency, there is a force on any structure on a part or a machine. What happens? It will vibrate. For example, tuning fork. Okay, so you are going to hit, and the tuning fork will vibrate. That is, we are going to apply some external agency in order to make tuning fork to vibrate. So next is there is a wind may also cause a vibration in structures like electricity lines, poles, telephone lines. Okay, so it may be a small structures. So those will vibrate because of the high wind velocity. If the wind blows more than 60 kilometers per hour, okay, these will vibrate. Okay, so like electricity lines, poles, telephone lines, and telephone poles, right? So these structures will vibrate because of the wind. Next, also the dry surface. Due to dry surface, what happens? There will be friction between the parts. Due to that friction, what happens? There will be imbalance and energy loss occurs. And due to that, what happens? There will be a vibration. Okay, so dry friction between the two mating surface is also one of the reasons for vibrations in a structure. So, how to reduce? So here, vibrations cannot be eliminated, but can be reduced to some extent. So what are the methods we have to reduce the vibration? So as I told you, we cannot completely 100% we cannot eliminate the vibration. Okay, to the maximum extent, okay, we can control the vibration. So what are the methods we have to control or to reduce the vibration in a machine member or any structure? By removing external excitation. So whatever the external agency or excitation which is acting on the machine member or a structure, that can be removed. If you remove it, the vibration is going to reduce. Next, using shock absorbers. So now you might have seen the shock absorbers in bikes, automobiles and all. So whatever the road shock is there, that can be due to irregularity in road surface. What happens? There will be shocks are generated from the road surface, and that is going to prevented by the shock absorbers in a vehicles or automobiles. So by using shock absorbers, that is, it may be high shock absorbers or spring shock absorbers, right? So those we are using in the automobiles, those will absorb the shocks waves generated by the irregular surface of the rough surface of the roads. Now next is by using dynamic absorbers. I told you we using absorbers also we can reduce the vibration by resting the system on proper vibration isolators. Okay, for example, if you keep any vibrating structure on any of the isolators like rubber bands, okay, cork, leather, springs, these act as isolator. Isolator is nothing but the material which or the member which absorbs the vibration and reduces the transfer of vibration from one part to the other part. These are called isolators. Okay, so in order to prevent, what we are doing, you are going to keep the entire vibrating structure on isolators like rubbers, cork, springs. So those are acting as isolators. So this is also one of the methods to reduce the vibration. That is by resting the system on a proper vibrating isolators. Next, some of the important definitions with respect to vibrations. Next, periodic motion. First one is periodic motion. What is the periodic motion? I told you, a motion which repeats itself after a certain interval of time or equal interval of times is known as periodic motion. Okay. For example, take a simple pendulum itself. Okay, if you just give some initial displacement, it will oscillate on its own. That is to and fro motion of a pendulum about the equilibrium or mean position. Okay, it repeats. Okay, every equal interval of time, it will oscillate about the mean position. That is called as periodic motion. A motion which repeats itself after a certain equal interval of time is known as periodic motion. Time period. Okay. To complete one cycle, how much time the body or a particle is going to take, that is called as the time period. The time taken to complete one cycle is called as a time period. Next is frequency. So many cycles per second the body or a particle is going to complete per unit time. That is maybe per second or it may be per minute. Okay, so number of cycles per unit time is called as a frequency. Frequency or the unit of frequency is hertz. Time period, it may be the seconds. Okay, so this unit of time period is seconds. Now amplitude. Third one is amplitude. Okay, what is into amplitude? Amplitude is nothing but the maximum displacement of a vibrating body from the equilibrium position or from the mean position is called as the amplitude. It can be denoted by X. Okay, amplitude is nothing but the maximum displacement of a vibrating body from its equilibrium position is called as a amplitude. Next, natural frequency. When no external force acts on the system after giving it an initial displacement. So I told you in case of simple pendulum. Okay, initially at the resting position. Okay, that is at the rest of state. So what we are doing is just you are going to apply some external excitation, that is initial displacement. We are going to give to the pendulum. That is you are going to drag and leave the pendulum. After it will oscillate on its own about the equilibrium position. That is called as a free vibration, and the frequency associated with the free vibrations is called as a natural frequency. That is, simple words, when no external force acts on the system after giving it an initial displacement, okay, and that vibration is called as a free vibration, and the vibrations associated with such type of vibrations is called as a natural frequency. Next, fund next degrees of freedom. Okay, this is not an important fundamental mode of vibration. Leave it. Next, degrees of freedom. You will ask your own definition on this. Degrees of freedom. Define like the minimum number of independent coordinates required to specify the motion of a system or a body at an instant is known as degrees of freedom. For example, if you take the fan, okay, it will rotate about the vertical axis. That is, rotation is an 1 degree of freedom. So fan is having 1 degree of freedom because it is rotation about the vertical axis. Theta is one of the parameter to measure the degree of freedom. Okay, so body, another example is body in a space will have 6 degrees of freedom. What are those 6 degrees of freedom? 3 translatory, that is linear translations, and 3 rotations, that is about 3 rotation about x, about rotation about y, and rotation about z. Okay, those are 3 freedoms. Next is another 3 is linear motion or linear movement about x, y, and z. 3 plus 3, 3 linear and 3 rotational. Totally 6 degrees of freedom will be having or will be possessed by a body which is in a space. So there is one more example. If you take the door, okay, it is hinged to the wall, and it can be rotated only about the vertical axis, that is about the y-axis, and only rotation is possible. No linear motion of the door is possible there. So it is a single degree of freedom system. That is angular rotation theta. Okay, that is single degree of freedom. Okay, rotation of the door. So like that, the degrees of freedom can be defined. The minimum number of independent coordinates required to specify the motion of a system or the configuration of a system at any instant is known as degrees of freedom of a system. Okay, I told you body in a space. There is body. Okay, it can move in x, y, z direction. That is linear motions, and as well as rotations about x, y, z axis. So that is 6 degrees of freedom we'll be having. Damping. Okay, so very important element actually damper in a vibration system. Okay, what is it by damping? It is a resistance to the motion of a vibrating body. The vibrations associated with this resistance are known as damped vibrations. Okay, so if you take the oil and the pot, okay, so in the vessel, if you take vessel, okay, if there is a oil that acts as a damper. Okay, so what are the vibrations which are developed? It will be prevented by that particular damper. For example, oil dampers which are used in the shock absorbers of a vehicle or a two-wheeler. Okay, there is a best example. It acts as a damper. Okay, so it will prevent the motion of a vibrating body. Usually due to rough surface, what happens? There will be a vibration. So to avoid that, they are using oil dampers. That is The resistance to the motion of a vibrating body is called as a damping. The vibration associated with this resistance are known as damped vibrations. Okay, so oil dampers are the best example for this type of damping. Next, resonance. What is resonance? Why how this resonance occurs? What happens when the resonance occurs? So whenever the frequency of external excitation or external force becomes equal to the natural frequency of a body, vibrating body, or simply a body which is having vibration. So now the frequency of external excitation or external agency becomes equal to the natural frequency of a body or vibrating body is known as resonance. At resonance time condition, body will vibrate with a maximum amplitude. Okay, so there will be a maximum amplitude will be there, and the body will be vibrate with the maximum amplitude in case of resonance. Okay, you might have seen whenever we in case of tuning fork also. Okay, whenever the resonance reaches, it will give some sound. Okay, and it will be vibrating with a maximum amplitude. Okay, so that is called as a resonance. The amplitude of vibration becomes excessive, that is large, and sometimes material failure also takes place. So always while designing any machine component or a structure, we need to keep the natural frequency of a body away from the frequency of the external excitation. Then only we can prevent the resonance and the failure of the structure or a part. Okay, can be prevented. So always to avoid the failure of a component, the frequency always while designing a component, the frequency of external excitation should away from the natural frequency of the vibrating body. Then only we can avoid the resonance and failure of the component. Next, important elements of a vibrating system. That is parts of a vibrating system. What are the main parts of vibrating system? So here the figure it is shown. Spring is there. It is represented by a spring constant K. Damper is there. That is damping constant C. Okay, and also the mass M. So the mass will be having some magnitude. Okay, whenever that is excited with the help of external agency or external force, what happens? It will oscillate. So now to reduce that vibrations, he has introduced two elements, that is damper and the spring. These are acts as the isolators. Dampers and spring acts as isolators. Those are introduced between the mass and the floor. Okay, this is a vibrating body and this is a floor. Okay, in order to reduce the prevention of the transmission of vibration to the floor, he has introduced two elements. Okay, those are called as spring and damper. This acts as a vibration isolators. So now come to the equation. So here, before going to equation, energy is stored by mass in the form of kinetic energy. Okay, so mass will be having some energy in the form of kinetic energy. There is half mx dot square. X dot means acceleration. Okay, and in the spring in the form of potential energy half kx square. K means is spring constant, x is the amplitude. Okay, this is a linear displacement. X dot is a velocity of mx dot square, that is kinetic energy stored in this mass is of mx dot. X dot is the acceleration, and in the spring in the form of potential energy of kx square. So the energy stored in the spring of kx squared is potential energy. X is the displacement of the body, that is a mass, and dissipated in the damper in the form of heat energy. So whenever the energies are developed due to the acceleration of this mass, by the vibration of this mass, energy stored by the mass in the form of kinetic energy, that is half mx dot square, and in the spring in the form of potential energy half k square, and these two energies are dissipated in the damper in the form of heat energy, which opposes the motion of the system. Okay, and energy dissipated in the damper, okay, in the form of heat energy, which opposes the motion of the system here. So what is that? Damping is nothing but it is a resistance offered to the motion of a vibrating body. So damper will absorb all the vibrations and prevents the amplitude of vibration by absorbing all the energy which are developed due to the mass. Which are developed due to mass. Okay. Now energy enters the system with the application of external force, that is known as excitation. The excitation disturbs the mass from its mean position, and the mass goes up and down from its mean position. That is, whenever you disturb the mass, that is with the help of external excitation, it will go up and down. Mass will go up and down from the mean position. This is a mean position. From the mean position, it will move up and down. Okay. The sequence goes on repeating and the system continues to vibrate. At the same time, damping force Cx that acts on the mass. So here, whenever the mass oscillates, this damping force Cx dot will be acting on this mass and opposes its motion. Now the mass, because of external excitation, oscillates. Okay, so that will be opposed by the damping force, okay, which is developed by the damper. The damping force is given by Cx dot, where x dot is the velocity, C is the damping constant. So that acts on the mass and opposes its motion. Some energy is dissipated in the cycle, in each cycle of vibration due to damping. So what happens? It will prevent or reduce that is energy dissipation is going to happen in each and every cycle due to damping. Now, after this, the equation of motion of such a system, such a model, that is spring, mass, and damper model, is given by mx double dot plus cx dot plus kx is equal to 0 for the equilibrium position. Okay, the equation of motion is given by mx double dot plus cx dot plus kx is equal to 0, where x dot is acceleration, x double dot is acceleration, x dot is a velocity, and x is the linear displacement of the mass m. So mx dot inertia force, damping force Cx dot, and Kx is a spring force. So like this, we need to develop the equation for this spring mass damper system. So this is parts of the vibrating system, and now these are modeled in this final equation we can see here. Thank you.